indeed is a topic that one has to have a clear idea about, so that one understands one can fit in, so that he can confine his narrow down his material that he has to go after, and take specialized trainings. Or else, if you don't have a clear idea, it might be quite possible that sometimes we end up a lot of time shifting, switching from one thing to another, trying to get a grasp of everything that's thrown to us. So with this, I'd like to start the first slide. Of course, innovation and development. We'll try to break it down into two sections: innovation and development, and then we'll talk about the technology readiness level. My experience actually is in the field of data science over the last 10 years, as our Autonomous said. So I would confine myself to this field itself. Otherwise, the topic is very broad, and it encapsulates almost everything, all line of technologies that we have in the world today. So I would like to share my understanding and the experience that I had in this field, and under this umbrella. So innovation, like it's not a very difficult term to understand. Like it is, simply speaking, it is creating, thinking about new ideas and putting it into some kind of product, some kind of service that is useful to humanity, society. At the same time, it should be profitable. So just having to just clear this, we talk about novelty, we talk about new ideas. But when it comes to the field of technology, novelty alone won't count as innovation, because any novelty that we come up with, any kind of new ideas that we come up with, has to have some kind of value addition. It has to be useful to society, and and preferably it should be profitable for industry who takes up this job. Or else it's difficult to pursue such a technology which doesn't profit you. And of course, there are schemes, like when we have welfare schemes to do, like someone would take up the cost and like try to push a technology forward, an idea forward, so that it gets helpful for the society at large. But very invariably, like the cost benefit has to come into play. And if you think of an idea which is at the same time which is useful to the community, and at the same time it's going to be profitable, then that would actually be classified as one of the innovation that we uh, can make in the world of technology. So when we talk about innovation, there could be two types, like there's type 1 and type 2. In type 1, we have we can just give an alternative solution, and mostly you would have domain experts who would be coming up with those ideas and those solutions. Whereas in type 2, we redefine the problem, and like from a holistic point of view. I'd like to just take an example to explain these two types in a little detail. Suppose we have let's take an example of a student attendance system that we might have in your college. Suppose in this time of pandemic, many, for a lot of days we had to work from home, and for some reasons, suppose like we decided to do some kind of remote authentication using mobile phone. So that could be like done using student verification system, uh, where you can build a system, have a server at your college, which has a list of all students and their voice signatures, and then the students can actually use their mobile phone and call at appropriate times and give their attendance. So in that thing, what will happen, like this could be a technology at the back end of which you will have a speaker verification system. So it could be a DNN-based speaker verification system. So some of the current things that we have right now is like I vector, X vector. So these are the different DNN architectures that we are currently using for speaker verification, speaker identification systems. So suppose we have that in place, and you have there's a group of researchers who would be working on it. So as we know, all technology takes time to get refined, and it might not give you 100% accuracy, which is why you can expect glitches. Many times it might so happen that like student tried to call, but it did not recognize. Why? Because there could have been some problem in the network. The voice may not have been clear enough. There could have been some noise because of current environment situation. It could be rainy season. So because of certain issues, I mean, there could be problems. And as a researcher, as a domain expert, what would one do? Like what one would actually work on the algorithm and see how much he can make out of the data that he has, so that he can actually better the performance of the backend speaker verification system. So if he comes out with new architectures, if he comes out with like new feature engineering, so that like he can actually make more out of the noisy signal or the corrupted signal that is has been transferred over the mobile network. So that would actually fall in type 1 innovation, where a domain expert uses all his knowledge and tries to dig down more into the problem and finds an alternative solution or a better solution that can solve the problem. In the same scenario, you can talk about type 2 scenario, where you have the problem. So the problem is like because of some environmental conditions or some network issues, the voice signatures sometimes fail the matching process. Why? Because it gets corrupted, noisy for some reasons. So the type 1 like innovators, what they would do, they would develop a better algorithm for it. Whereas in type 2, what will happen, like you'll have a more holistic view about it. You know about the whole system. You know about the problem that is like that the whole system is facing. So what you would do, you know that it's a student, it's a college, it's a student who's trying to register his attendance. So it may not be very critical if we just ask the student to just repeat what he said. We may simply like have uh, a different measure of we can measure the speech signal, get something like SNR, signal to noise ratio, and see if the quality is good enough at the very beginning, without even trying our speaker verification backend system on this. We can just check if the signal is good enough, or if it is noisy. We can have a process where we can just ask the student to just repeat his words. So you see, this is in here. It doesn't take much. It's not that critical. If you ask the student to just repeat what he said for 2-3 seconds, then it won't be a problem if you do that. So we can have a system where we can actually ask the student to just repeat what he said, and so this time when the noise is clear, then next time we check if everything is good, we pass on to the backend and we get things verified. So the same problem could have been it was solved in a different way. Okay, so this is something. When you have a holistic view about the whole problem, then you can solve things in this particular fashion. This is more like an engineering solution to the problem, rather than digging deep into and researching how can expert existing architecture, the existing algorithms that you have. A very similar and common example that is given in the same context is like regarding computers. You see, our computers, the one thing that we demand of computers, like it should process very fast. So in the initial days when we had a processor, then it wasn't that fast. So with time, like things got faster, and who played the role in it? Like mostly the VLSI industry. They came up with like one technology after another technology, 80 nm technology, like 180 technology to 130 technology. This process went on, and they went on innovating, and the researchers really dug down all the things, and they were able to find out I mean, more and more optimum kind of length called the channel, as we say. And then they came up with a fast computer. I mean, like faster computer. So that actually follows in type 1 category. Now, when you talk about type 2 category, like instead of like really working so hard with the at the core of that VLSI architecture that we have, we might as well like add more than one processor. You see, that's what happened when we had multi processors, like more than one processor. So even with that, our problem was addressed. We got a faster computer. So that is like a type 2 kind of solution, where we have where we can actually take a more holistic view of the thing, and like uh, and and give better solutions. Uh, so this is what innovation would be like defined, and these are the two types of innovation that we can think about. Now, like since I already mentioned, like I would be confining myself to all that stuff related to data science stuff, since my experience and understanding is more in this field. So what about data science? Data science, like you have to work on some data that is available to us, and good product and viable product out of it, that is called data science. It's as simple as that. You have a lot of data to yourself, and you have to understand how you can make good use of it. I mean, by use you mean you have to have a, you know, some service that you have to create so that it helps society, and at the same time it can help you earn good profits. So as mentioned, data scientists just transform data into some actionable products or insights. Okay, so when you talk about innovation, so what kind of innovation can data scientists make? I mean, all the things that I've listed out there, I'm sure all of you must be known to you, must be known to you all. So the point that I'm trying to make here is like, you see, we have data, and what are the innovation that can we make from here on? So you see, like in stock market, we come across so much of data on a daily basis. People are trading, company stocks are going up and down, and like people are trading, making money, some are losing money. So like, we have so much of data going around. You have data about how the company is doing business. Is it getting good business? Is it getting, like, is it falling short of projects? So there's so much of data around. So as data scientists, like, you can innovate uh, an idea where, like, you want to build a system that would help you predict the stock market. I mean, whether a particular share's value is going to go up or down. So, like, that is kind of innovation, an application that you a data scientist can come up with. I know this is very trivial, but this is just to like, stress on this fact that, I mean, when you have data, the way you innovate could be, like, something which actually helps you to uh, get a viable and useful product, at the same time cost effective. So you see, churn and score analysis. Churn and score analysis is used by a lot of industries nowadays, which is especially car makers and whoever has to sell anything. So suppose you have a car, and, like, it's from a particular, it's of a particular build, particular make, company, and then over a period of time you got fed up of that company. You might try to go switch to a different brand. So I mean, the company has to collect all the data, your actions. Are you accessing the services? Okay, are you using their, like, service center more often, or are you, like, is there any review that you are following? Is there any brand that you are following up in the social media sites? So they will collect all the data and find out if that person is still being loyal to the same brand or is trying to change the brand. Depending on it, the company can actually take measures to help, like, itself retain some of its customers so that it does not lose business. So at the same time, like, having the data, a data scientist job is to, like, think of a product that helps uh, the industry, the corporates, to retain their business and to increase their profits. At the same time, like, you have network security. I mean, this is of course not an area of my specialization, but the same thing follows out here, because we have a lot of algorithms to take care of network security. But with the coming coming advent of this lot of data and a huge repository of data from all sources over the network, it might, like, the data science can actually help build a tighter and more robust network. So the same with the biometric system, the example that we talked about in the beginning of this um, talk, and where we have, there's a lot of people around. If you talk about of a college, of a class, we have around, like, 60, 70 odd students. But when you talk about a service nationwide, there will be crores of people. So when you have so much of data, if there's a system, if all of us log into a biomet, all of us using some social media application, we have all of us, like, give our identities. So in a way, we have so much of data with us. So in a similar way, like, if we are dealing, like, services over call centers, and whenever we go and buy some, uh, every product that is being sold has an associated call center with it. So there's so much of data that is collected by all of this. Of course, the privacy concerns and all are taken care of. So much of data is available to us. Then, as a data science, you have to think how can we make better use of it. So the biometric systems that are being built actually lends the company a very good alternative to help understand its customer and not waste time on authentication. And immediately, if that particular customer already had interacted with that, suppose call center, They may not like to waste time like trying to get the authentication done if they have a biometric system in place. So this actually will help their profit, help them increase their profit, and at the same time like avoid people who are like faking identities and trying to get into others' business. So similarly, you have recommender systems like when all of us are using uh, online shopping sites nowadays like Flipkart, Amazon. So you would realize that like every time you buy a product, there's always some kind of recommendation from the computer systems. So how did it come? It's just because we have been using it for a very long time, and there was so much of data that that was actually indicative of our choices, of our needs, like, of our taste. So the data science, with the help of data science, we could actually use those data and actually build a recommender system so that like the customers could be provided with those easy choices without having to think much. So this actually increases the chances of the customer buying that product along with whatever he was looking for. So that way the business gets a boost, and which is why like this is so crucial, and everyone is using it these days. So we have similarly, we have sentiment analysis, which is helping many companies decide whether the customers need some kind of modifications in the services or not, so that like, they don't lose business. So this kind of once they have data from the customers, they would like to from the reviews they are giving for the company, because it is in a big scale, so you cannot go line by line and read each of the reviews. So when you do sentiment analysis, you understand what is the gross sentiment against or for a particular company. He can take measures like this, so that will help him save business. And so you see, there was data available, and these are the innovative products that one has to. Of course, this existed for a long time. It's the process that we are trying to understand here. So these products actually help the company gain more business and also retain more customers. So like no, so these actually innovation leads to more technologies. There will be many more technologies coming up. So some of the ones which are very trending nowadays are, of course, artificial intelligence. Then you have cloud services. Then it's augmented reality. We have virtual reality system. Of course, we all know about IoT, the Internet of Things. So digital twins. So artificial intelligence, of course, like it's all over nowadays. People are trying to use it in uh, in whichever way it is possible for certification, for recommender system, and like for building models, for understanding people. You have the conversation AI where a person can actually interact with the machine without even realizing that the person is actually a machine. So you have such intelligent systems nowadays. Okay, when you talk about cloud services, actually we are talking about services like Amazon Web Service, Amazon Cloud Service, you have Google Cloud Service, then you have Azure from Microsoft. So why these cloud services exist? Because with, because when you develop a product, suppose like you have used artificial intelligence to develop a product, you want to uh, you have want your stakeholders, all of your stakeholders to use it, and once your product is successful, it has to be scaled up. So you see, a particular product gets successful, it has to be scaled up. That means a lot of other people will be trying to use your service. So the burden on your PCs and servers and computers would increase immensely. So it may not be viable for all the companies to have their own servers all the time, because you don't know to what extent you have to scale it. So which is why like if you have cloud service, if this cloud service provides you with good GPUs, good servers, and a technology which helps you to scale things up in a very efficient way. So it's nowadays this is quite trending, and most of the companies are actually providing the services over cloud until and unless they have some security issues. So these services, this technology has been growing in a very fast-paced way, and a lot of scope. It brings along with a lot of scope, and people studying, I mean, working in the data science area, like it's a must for them to know this, because all the companies would be actually hosting their products over cloud and also working on the cloud to train the models, because individual companies, it may not be cost effective for individual companies to own all the GPU systems, all the server systems, so they could better use these paid services, and which is why this technology is getting a boost, and whoever is working in this specialized technology has got a lot of scope. Now we have AR, the augmented reality, we have virtual reality systems. Uh, that we often talk about, like this is something like we are looking into future, so to say, like where, like, I mean, I'm sure like you must have come across this uh, virtual reality or augmented reality kind of games where, like, once you get the headset on your head, like you involuntarily react as though you were in some virtual world and not in actually not realizing that you're still, like, very much in the same place where you started. So this is quite interesting. In future, you could have you could see things like, materializing in a much concrete way, and that can change our lives. And you see Internet of Things. This again is an emerging technology, like, because we have data all around and we want to share data among all the devices we have. Each one of us are using multiple devices, like we are using laptops, we are using pages, and we are using mobile phones. So and then we have, I mean, we have accounts in a number of different applications. So we want all to be connected. Because we have, like, health. We try to monitor our health using many devices. So we want everything to be connected. There's so much of data to be shared, and so which is why this particular technology is, like, finding a lot of scope. So we talked about digital twins, like recently when Facebook. I mean, when we changed the name to Meta, you see, like they're talking about metaverse, where each one of us in future might have a digital twin. So these things could be very interesting and exciting. So these are the technologies that have been emerging, like, over this time. And then you have quantum computing. This is a very promising kind of technology where, like, the computer could actually process things in a much faster way. It is still in its initial stages, and some studies say, like, in 2020 year itself, like it can be in use, like, for many good things. So to talk a little, just talking a little more about artificial intelligence, just to go through the kind of applications that are possible with artificial intelligence. So we see one of the most, like, popular kind of application these days is, like, in the field of medical science. Artificial intelligence being used to diagnose problems and diseases, like, quite early, and helping medical practitioners to take precautions early enough to avoid further damage. So there's a lot of work going on in the world of bioscience. You have bioscience, then you mix up with artificial intelligence, which is helping you improve your diagnostic techniques. So this has got a good market, a very big market, and it's got accordingly, there are a lot of jobs available in this area, and we need people, like, who are specialized in this particular domain. So this is one application where, like, of artificial intelligence, which is gaining much attention. So we often hear about autonomous cars, like, which are self-driving. Like Tesla is one name that we all of us know about. They have the self-driving cars, which are full of their systems have got artificial intelligence, like, in to a big extent, like everywhere, like, artificial intelligence being used to make things easier and automatic. So another, like, area which is getting prominence lately is, like, natural language processing, speech synthesis, voice cloning. We are trying to build robots and chatbots and voice bots which would actually replace uh, real people. So that would actually help bring down the cost of many companies, industry, and at the same time offer better and more, like, user-friendly experience to its customers. We already talked about stock trading. Well, like, to try to use the data to predict the rise and fall of shares and help investors make proper decisions. So more like, artificial intelligence has found a big market in the field of gaming technology. Uh, you have so many games like AlphaGo, Dark Forest, and you talked about, like, Alexa, like, which is Alexa and Siri that we have, which can talk to you uh, when you have some queries. It is able to, like, provide you with those queries, and it gives you almost like you're talking to a friend of yours. So artificial intelligence has found its market there. It's found a lot of application in these areas, and it is only growing in this time. So the other things like anomaly detection, image taking, which you have so much of data, so much of cases to deal with, so things has to be has to be automatic. So this artificial intelligence is helping people develop such systems. So I mean, since I understand like a lot of our audiences, like from the student community, so having understood like what kind of innovation we can do, like if we're in the field of data science, and what kind of technologies that is being emerging nowadays. This is the list of all the roles, few of the roles that you can actually take up uh, like to contribute to this technology, to be a part of this growth of technology. So you could be AI analysts and developers, you could be NLP scientists, like it's a natural language processing scientist, of course data scientist, then you can be a machine learning engineer, deep learning scientist. These are the different roles that you might have. You could be AI researchers or algorithm specialist, or you could be from the field of biomedical, where you could have special domain expertise from the field of medicine as well, so that you can take up jobs like surgical AI technicians. So these are the different roles. One as a student, you can I mean, you can aspire to take on, so that you exactly can decide what you should be doing to achieve this kind of profile, so that you can actually catch a job of this in this particular roles. So so that we have talked about, having talked about innovation and technology, then we understood like your technology emerging, and the different roles that one can actually take up. So it is very important to understand how this technology uh, progress goes on. I mean, from the beginning till the end, how does the technology matures and how it is put to the market. So if you go by the definition, it is a method for understanding the technical maturity of a technology during its acquisition phase. I mean, you see, it was first introduced by NASA for its own space exploration technologies in the 1976, way back, and it still holds good in today's time. So it just measures the level of maturity of a particular technology and how ready it is to actually get deployed. So I'll talk more in terms of data science. Here you can see you have three sections broadly. Like you have to start with research, and you have to research that thing. Then you have to develop that thing. So you have research, then you have development, and then finally you have to find a viable way of deploying the thing. So these three sections, this when you talk about technology readiness level, they talk about the 9 levels actually, starting from 1, 2, 3, 4, 9. Ninth, when you start 9, you just see the business problem, whether it has got any use or not, whether it's going to be helpful, is it viable. Then that is the basic way you start. Suppose one, and then as you go on, like researching, finding out algorithms, developing products, then testing, then demo testing, then you go simulate environment and put your product into test. Once you're done with it, and finally you are ready to deploy it in real world to be used by customers and target audience. So that is the level 9 that we talked about, when it is finally uh, like, ready to go to the market. So in the field of data science, we follow a similar kind of pipeline. It is actually named as CRIPS DM. It stands for like the Cross Industry Standard Process for Data Mining. It was published in '99, and it's been invariably used by a lot of data science companies in their pipeline. I would say like they don't follow it very strictly, very loosely. I'll tell you why loosely, because nothing is very definite when it comes to uh, the pipeline that we use for data science project, because many a times we have to go to and fro, come back to basics and redraft and devise things to just solve the problems that we might face every time like we come up with a model. So basically there are 6 phases. Like you have to start with the business understanding, what is the need of the business, and then you have to start with your data understanding, like is it appropriate, whatever data that you got, and you have to prepare the data well, and then you think about modeling. So how will you model it, using deep learning techniques, using machine learning techniques. So and then you have evaluate it, and after evaluation, as you saw in the last slide itself, then we have to deploy it in real life situations so that it could be used by people. So these are the 6 phases that we have when we talk about like CRIPS, the cross industry standard process for data mining. More or less, people in the field of data science, they follow this pipeline, and they are, as I said, sometimes they follow it a bit loosely so that they can come and go for sometimes to get some feedback and better their algorithms, better their data, and the whole process altogether. So just so you see, this is a cycle. It's a never-ending cycle. So once you have a business understanding, by business understanding, I mean like what does your client want? I mean, you see everything. If the client doesn't is not looking for a solution, then probably, probably dwelling into it would be futile. I mean, not of much use, because the client, you have to understand what the client is looking for, what is the public expecting. So this is kind of business understanding that we should have. Like, is it viable? Like, investing in this technology, is it going to be profitable? Is it going to be useful to society? That kind of business understanding is something which is the first step in any of the data science projects. If it has got no use, or it is not, if it's not viable, profit wise, then we don't even start with it. So once you have the business understanding, then you have to have the data understanding. So there in data science, you need data to start with. So obviously, if you have a client who is looking for some solution, then you would ask for uh, data from the field, so that you can have an understanding. And once you have the data, you try to understand whether this data would be good enough. Does it really represent the problems that we are trying to address? And then once that phase is done, then we go to data preparation. And I'm sure, like any of our graduate projects that we do, I mean, many of the students who must have tried doing a data science project, they must have downloaded some data sets from the net, which they have already got the data prepared actually. But sometimes, of course, we understand the problem, then we can collect our own database and work on it. So that also happened. But mostly, when we're doing our graduation, we don't have much resources and time, so that we get ready-made data that we available, that has been open source and free to use for research purpose. So we get data which is already prepared. So the business understanding part and the data understanding part is already done. So once you get the data, then you start thinking about your problem and what kind of modeling you should do. Should you go for a regression problem? Should it be a classification model? And all those sort of choices that you have to make depending on your understanding and your experience. And then we have evaluation, and then we go to again business understanding. If it's okay, I mean, if evaluation looks good, then you deploy it. But once you deploy it, as I said, like, things are not 100% correct, so you'll face issues. You'll have some feedback. You have to go back the whole cycle again. I mean, you might just realize that, oh no, we need a different kind of data for this. We need additional kind of data for this. So you go to the you just redefine the problem that you have for your business, and then you get some more data, different kind of data. Then you process it again, and this cycle will continue till that and your product will get better and better with time, and it will suit the requirement of the business. We'll discuss these the things in more detail in the coming slides. So, as I said, like, this is an iterative design process. Initially, you start with something called build a minimal viable product (MVP). Okay, this is a technical terminology that we often use. So it's a minimal viable product that we start with. Once we deploy it, then we can start. The client would report issues. There will be feedback. Then we have to go back to our basics, and we define the problem. Have a look at the data in a deeper way, in a closer way, so that you can understand what's the problem happening, so that we can make changes in our algorithm. Then we go and model it again, and then again go for evaluation, again deploy it, and then it also improve some of the issues, but we can again get some new issues. And so the same process has to be repeated. This is how, like, data science projects, when it is when it is sold to some industry, some clients, it's taken care of. So, as I said, it's a business understanding. We have to have the objective of the business. What kind of solution it is trying to provide? Is it some kind of are you going to provide a voice bot solution? Like, are you going to provide a biometric solution to some problem, or are you going to provide a model which helps people uh, predict the stock market trends? So what kind of objective is that? Is it so once you decide upon it, then you'll have to understand and analyze whether there's a scope of AI. You see, this is a very common saying nowadays, that data science is science. No, it is not data magic. So it is data science, not data magic. So it might be quite possible that data science doesn't have a solution to this. So you should know, if you can understand that early on, so you avoid wasting time and effort and resources on trying to pursue this particular goal using artificial intelligence or data science. So it's important to analyze and to have the insight that this particular problem can be solved using data science, or it may not be solved using data science. So then we, as a for people who have a business understanding, like they have to have an idea of success metric. You see, like whenever we build a model, any system, we talk about the accuracy of the system. These are the metrics. I mean, we understand how well the model is performing, how well the particular algorithm is performing. We get to know from the accuracy, and there's a lot of measures of accuracy and performance like that. So similarly, a lot of metrics. So, but in case of this particular context, success metrics, it may not be exactly same as the metrics that we talked about when we are in academics. So, I mean, the accuracy of the system that suppose we talked about the student attendance system. So, the accuracy of the backend model may be 90%. Okay, but since as I said, like you know got around the problem, and like you were able to actually discard all the files which were noisy at the very beginning of the system, the very beginning of the system, so that like whatever data went into the backend model, it was all clean and it was correctly verified. So if you talk about business metrics, your success metric is actually 100%, not 90%. So the business metric and the actual metrics may not be same. So this is very important. Okay, I mean, if you have a business problem, like which it's good enough, it is happy enough to have a 90% accuracy, so you won't go and put your effort to get a 99% accuracy out of the system. So it will be futile and it will not add value to the company. So that is why, like, you at least have to determine what is the success metrics. Okay, yeah, if it's a student register system, you don't want to, like you don't expect people to fake other people or play. I mean, there's food detection that has to be done as well. So you don't expect your students to, like to be fraudsters, and that will never happen. So you don't have to go into, like, incorporating another kind of food detection system as well, so that, like you know that this kind of business at this place is something which we can do even without. I mean, we can do without. So we don't have to really go and put our effort into this. So this kind of a success metric has to be determined in the beginning, so that we understand how well our product is going to work. So there could be many ethical issues as well, like so the data, most of the data that we have over different accounts that we share with the different accounts over social media, over shopping sites and all, like it is given on the contract of some privacy. So once, if we are trying to use it, we have to make sure that it is ethical and we have proper permission from the clients or the people or the stakeholders to use their data for our modeling purpose. Okay. And also, like when we talk about the business understanding, we have to have a look in the industry practice as well, so that we can compare and see uh, how where we stand, or if we already have a player, like he's doing very well and we don't have anything different to do, so it might not be a very viable thing to go forward with. So there could be consideration like that, or if you're thinking about something and there's another industry practice, like which tells it can be solved in some other better way, so obviously, like you have to look into it and redefine your problem and your algorithm all over again. So this is the first part and the most important part, like when it comes to any data science project. So once that is done, like you understand that this is something we're going to build, then you have to have an understanding of the data. So you have to see which is the source and the character of the data. By character, I mean the quality, and sometimes like noisy data, sometimes clean data, sometimes the samples are too few. So you have to have an understanding of how, if you've been working in data science, like how important data is, like I mean, if your data is little here and there, like your model could just go haywire. So it is very important to have a good understanding of the data, like it has to be representative of the problem. Like if you're going to build a biometric system, it won't be sufficient if you just get 20 students voice samples and build your biometric system, because the variety is much more. I mean, of course each one of us has got a different voice. I mean, so, but like still we can represent in a generalized way, uh, provided we take a take the samples from a large population of students, say around 2,000, 3,000 students. Then we can actually have a generalized model which actually will be helpful to compare different voice prints and do verification. Then we have to look at the quality of the data. Sometimes the quality is too bad, like your model may not be in a position to learn anything. So that we have to understand. If these things don't work, if we think this is not going to work, then we have to go back with our business understanding and then see like if we can get data which is relevant to our problem and which is actually should be in a position that tell that this data of course can be used to build the model. So otherwise we'll be stuck in a loop and we'll not be able to get any accuracy and that would waste companies time and resources. So like once we are done with understanding data, then we have to prepare it. We know we have got enough data and relevant data, and we know that we can model build our products. So that we have to prepare the data. And as I mentioned earlier, like this is the data that we often get when we try to download some open source things, data sets like the opener in like CSV format, JSON format, and something like that. So when you prepare data, you have to follow certain kind of nomenclature because you would be using programming anyways for file processing, for processing images or audio files or whatever it is. So it's important to build to have a nomenclature. When you prepare your own data, it is very important to have your own nomenclature. Suppose you are like for the same speaker verification system, if you are able to, if you are willing to collect data from the field, so once you do it, you have to be very careful. Like you have to have a nomenclature for speaker ID, for region ID, because the region of the person is going to have an influence over his voice print. The mother tongue of the person, like everyone, I mean, English has most of us, it's not our first language. So the mother tongue has got a good amount of influence when we speak. So have to, it's very important to get a detailed detail about all those factors which are going to have an influence in the accuracy of the system. Okay, and the dialect of the person, then where was that particular sample taken? How's the environment like? Was it a market situation? Was it a closed room or a clean room? Okay, what kind of device was being used? Like, did you use a recorder? Did you use a very high fidelity recorder, or was it just a mobile phone that you used to record the sample, or did you do it through some telephone channel? So those factors have to be recorded precisely, and that thing will actually help you prepare and model a better system. If we are missing out any of this details, we might not be able to exploit this these conditions where we know that the certain factor which have an influence on the voice of the people, on the voice of the speaker. So we'll miss out on that, and maybe we not be able to reach the kind of accuracy that we'll be looking for. So similarly, like you have to mention properly what are the codecs using when you save your files, the timestamps if possible. Like if you're trying to build an ASR system, so automatic speech recognition system, so timestamps and many other things would be important. Sampling rate is also important. So you have to keep a record of all these things while you are preparing data. So like when it comes to computer vision, there are a lot of factors like illumination, camera resolutions, whether it is natural light, artificial light. So that has to be recorded properly so that you can make more meaningful insight out of the data. And once you're done with that, like you're going to train a model, so you need a training set. You once you train a model, the kind of system that we have, like we try to define find in the hyperparameters as well sometimes. So for that we need the development set, and of course we need to evaluate ultimately how our system is working. So we need to have a test set. So like it's very important to actually separate these things out in the beginning, or else like if there's any overlapping, then you might actually be misled into understanding how the particular model is working. If the train and test set are overlapping, so I mean, you would get a bit, you would actually, when you evaluate it, you might get very good results, but the thing is that there was some overlap between the test set and the train set, which is why this is happening. So when you take it out to the field, and you would not be able to replicate the same kind of performance. So it's very important that you actually separate this set so that you can have a better idea about the performance of the system when you evaluate. So data engineering, it falls under almost the same category where you have data engineering. How do you use a lot of programming languages like Java, Python, Ruby to do this kind of stuff. And if when you talk about big data, when you talk about big businesses, there are frameworks, tools altogether like Hadoop, Apache Hive. Okay. And like when you do data engineering, there's specialized framework like Apache Airflow and all. So this helps you actually pipeline because there's a lot of things involved, like starting from collection, from nomenclature, some cleaning, a lot of stuff, and this requires a very systematic approach. So if you falter in any of the point, then it's going to have a immense adverse effect on the performance of the system. So this is a very organized uh, area where data engineers use all their programming skills and understanding of data to prepare data. So data science people can actually build models, right? So you see, then once you have the data, it is prepared in a proper format, and you know what data engineering has to be done. You did it, and then you have to decide whether, depending on your experience and the kind of understanding you have, you'll be able to tell whether you should go for some machine learning algorithms or you should go for some deep learning algorithms. So our one basic thing that we know is that when we don't have much data, so it's always preferable to use machine learning algorithms. But if we have this uh, luxury of a lot of data, then sometimes deep learning algorithms give us better results. So we have to make those decisions depending on the kind of data that we got from our clients. Right. So then once you have those things, then before we actually go on building the model, you have to have a statistical analysis of the features that you have. Are they like significantly different? You know, the data engineers must have provided you with some kind of maybe data features maybe. So we have to analyze well whether those features is there a significant difference between the different classes, when in terms of the features that they have. So this statistical analysis is very important before we go forward trying to model the system. So the different frameworks that we have to select while modeling, some of the commonly known frameworks are like PyTorch, then you have TensorFlow, then Keras. I mean, I'm sure like many of you might be using those things. So these are the consideration that one has to have like while modeling. And finally, when you evaluate things, there will be a metric. As we already mentioned, this metric, the business metric may not be same as the metric that we use, especially when we do our theoretical studies. The business metric could be very different at times. So we have to think in terms of the business metric most of the time when we build products for public use. Okay. And evaluation, you see, as I mentioned, like if there's any overlap between the training and the test set. I mean, even if not the exact data is being overlapping, it's a kind of suppose like you have data from speaker data from market condition, and again you tested on another speaker data from the market condition, that is also will create a bias. You should be you have in your test data there should be speakers, I mean voices from speakers who have given the samples under different conditions, some classroom, some in airports. So you have to have a variety there. Otherwise, there will be a bias, and whatever you get performance, it not be reflective of the actual performance of the system. So this has to be taken into consideration very seriously, of course. So, and we'll see if it matches our business objective. I mean, whatever performance we are getting should match our business objective. As I mentioned, like if you have a student attending the system, as long as it is uh, like, you know as long as like it is meeting the objective, like we are able to verify the student. And sometimes, of course, when the students because of the network issues or the environment issues, if the system fails, we have a get around where we ask the student to repeat his sentence or utterance again, and then we are able to do it. So that way the business objective is met, and so we can stop there. Okay. Okay. So finally we come to deployment. You see, when you deploy things, a lot of factors come into play, like stability, latency, and privacy, user experience. So when you deploy a machine learning product, you have to deploy it in some kind of server. I mean, we are clear with that we have to deploy it in some kind of server. It could be a personal server with a company, or as I discussed earlier, it could be a cloud service. It could be Google Cloud Service, Amazon Cloud Service, or Microsoft Cloud Service, where we can actually deploy our products. So stability is an issue. As more and more people start using the system, there will be a lot of burden on the computer resources. So if it has to, I mean, one has to uh, keep the scope where it can be scaled up. Like instead of 1,000 people like accessing the system, within 1 minute there could be like 10,000 people accessing the system in 1 minute. The system should not hang. The, the user experience should not deteriorate. The response should be fast enough. So that's why we talk about latency. Okay, and at the same time, like when someone interacts with you, there can always be privacy concerns. So being a product developer, one has to also take care of this, that the privacy of the people or the clients who are using your system, who are using your service, are kept intact. Okay, and we always try to give better user experience to people with the development setup, with the deployment setup. So this of course finds it's a whole area, like it's all together, because a lot of people find themselves like totally involved in this deployment section itself. I mean, you have cloud thing to take care of this latency. I mean, sometimes you have a product which is actually could be too big, so you want to decrease the footprint. By footprint, I mean like the amount of memory that a particular model might take. So it might not be suitable, like for some applications where there's not much of resources available. So you have to reduce the footprint. So and so that, like when you reduce the footprint, things become faster. If suppose you have a big architecture giving you good performance, but you want like things to be faster, so you reduce the depth of the network maybe to get things faster. And this is just hypothetical. So you reduce the depth of the network. So, but without there will be some compromise with the performance, but at the same time you have to consider this latency factor. So you want results immediately. So that could also be a solution where you actually compromise a bit with the accuracy and bring down the size of the network architecture that you have, and like cater to the latency factor as well. So these are the 6 phases that we talked about. You see, when it comes to, yeah. So then, like we talk about like commercialization. Of course, like this is obvious from his name. Like once you have a problem, when you have a product ready, like you have to do a lot of marketing, a lot of promotion, okay, and to reach the target audience. So before that, like this commercialization has, it's not a thing that you start doing like after the product is ready. It's something like we have to think beforehand, like, in hindsight. So that, like see. You have to see the demand for it. Only then we go forward and like and start building the model. We understand the business problem, and and so we want to solve it. That should be the attitude. So we have to see the demand, and then only we can proceed and see, like, if with the available data that we have around us, is there a way, and the kind of technology that we have around us, is there a way to solve this problem and make a market for this. So also at the same, the return on investment. So when you go on building this particular product, you have to involve a lot of computer resources. Okay, the costly GPUs that you have to buy, or sometimes you have to have you can have subscription as well from those cloud service providers. So those will incur a lot. Of course, at the same time, you have to have resource people who would be working for you on this. So there will be a lot of investment. At the same time, once the product is ready, I mean, it may be the best product in the market, but once you are, once you're selling in the market, and then if your clients and your customers start using it, if the return is not as per expectation, or if it is not even meeting the cost of the product building process, then it might not be a viable project to go forward with. So the return on investment is very important, like consideration to make, and it's done at the very beginning. The analysis to be done at the very beginning of the whole process. Okay, we have to especially understand which is our target audience, which we are trying to take care of. Sometimes, like, you want to build some gadgets, sometimes for some gadgets for disabled people using artificial intelligence, data science. You have to know your target audience. One way is, like, for social welfare, you will be doing it. At the same time, if you have to sustain it, it has to be profitable, or at least funded by some sources. So you may be targeting, like, suppose disabled people, or maybe you may be targeting like old people who might have some problem working. So you build a product which helps them, like, do their jobs automatically. So you have to determine your target audience in the first place, and see if your product that you are thinking about, the problems that you're going to solve, is going to give you some return on the investment that you would take up, would make eventually in the making of the product. So this is so common that we have to promote the product, so that more and more people know about it, about its benefits, so that they can uh, little have it and use it at the same time. So then we do marketing, and there has to be a sales plan actually. So these are very specialized areas. I mean, I have to confess that I don't have much experience with at least this part of the process, because there are different and like specialized sections who take care of it, and we have, yeah. So as I talked about, like the whole machine learning flow, the trips that we talked about. So you started with business understanding, you went data understanding, then data preparation, then you started with modeling, okay, and then you have to have evaluation, and then again you have to come back and see if there's any issue, they have to resolve it. So doing this, like it's a whole pipeline. There are systems and platform which helps you maintain the life cycle, and maintain and the life cycle. At the same time, it helps you to actually organize things in a proper way, so that you can track how things are moving, whether your accuracy is improving, or it might so happen that you make some changes, and after making those changes, your performance deteriorated further. So you may be doing it repeatedly, and to keep a track of all those things, it is important, you use an automatic software. So this like MLflow is like open source platform that actually helps you manage all that you do, in a machine learning life cycle, starting from data preparation to like the deployment of the product. Okay, when we talk about the model training frameworks, like we have PyTorch and Keras and TensorFlow. I mean, these are the most common frameworks that we use to build our deep learning or machine learning models. Okay. And when it comes to deployment, Flux is not a very like production level framework, but most of the time, startups and like companies, many companies would like to use Flux to actually test the model first up. At a small level, when you want to test your model, you can actually put it up using Flux. I mean, the students from the computer science background must be very much aware of this. It's a very lightweight weight framework that is being used to test. You can actually put up your product as an API, so that everyone can actually hit it and get the service out of it. So a more professional thing is like Python with Django framework, which helps you deploy models in a faster way. So as we said earlier, we have this whole cloud service going on. So sometimes, this container-based API is also being also getting very popular these days. So we use Dockerization. We use Dockers. So once you build a model, we understand, like suppose we have a system, we have a GPU, we have an operating system. There must be a lot of libraries that we used, okay, and then we have built a model, and this model must be having so much of dependencies all around. It must be dependent on so many libraries all around. So when you want to transfer the same model elsewhere, and you have to actually install all those required dependencies again all over again, and sometimes the version might not match, and so many issues might come up. So this Dockerization is a very useful technique, where you you Dockerize the whole thing and make a container out of it, and and when you port it to some other computer, you don't have to do much. You just have to take the image there, and you can run this Docker, and it will start working straight away, because it will have all the dependent libraries and everything that it requires in itself. So this is the way we package things, and mostly it is very fast track. So many companies, data science companies, are using this particular technology, where they package their thing as Dockers and give it. And when Kubernetes is a framework, it uses Dockers, and it takes care of all the scalability and DevOps stuff in the cloud service. It's a paid service actually. So this is one technology where a lot of people are working, and this itself is a huge area where a lot of people are working dedicatedly. Then we have things like engines and all, which helps to balance. This is a load balancer actually. So suppose you have a Flask-based system, so your Flask could be just Flux API could be running in one particular PC. Suppose for your graduate level project, you build that machine learning ML based DL based product, and you wanted your fellow students or teachers to test it. You'll up the API using Flux, and then it might so happen that you might be getting so much of requests from a lot of people, So who would like to use the same API? Then, like, your machines might be to the RAM and the processors, number of processors would be not in adequate amount, so might have to use multiple machines. Okay, so you have to put your API up in multiple computers. Then something has to coordinate all of it. So these engines will act as a load balancer, and this is very commonly used actually. So it acts as a load balancer. So you actually hit at one API, and depending on whichever API, whichever computer is free, it will be directing the customer request, the client request to that particular instance of the API, and this way you will be able to and balance and cater to more clients at simultaneously at the same time. Okay, so yeah.